Okay, guys, I want to show you something here with the Segwencer and also how to use offset voltages. I got a freaking tripod directly in front of me between me and the Synth, so it's a pain in the tuchus, so I'll do my best. First of all, I brought in this cool quad LFO. Very simple. No inputs, just outputs, one for each. And for each one, you've got a rate control. If you push the switch in and let it go, now it's fast. I almost always use it in the slow speed for slow modulations, unless I want, vibrato. Sine wave, square wave. That's as simple as it is. So we'll use LFO 4 as a control signal. These are the inputs for the different things that are being segwenced, different oscillators, pitches, or control signals. This is the control voltage end to tell it what to do. So first of all, I'm just going to show you something. This is a number 4 sine wave into the depth input. I've got it in peaks mode. If you look at the website that I linked last week, it shows you graphic pictures in different colors of what the difference is between peak and slope, and it also explains what's happening here, okay? The depth amount will say how much is it listening to that LFO. So you can turn this up and then notice what it's doing. Now, one initial problem you've got is that the LFO itself is a bipolar signal. It's going positive and negative, and this is not AC coupled. So this is just disregarding negative voltages. So essentially what you've got is called half-wave rectification. It's only responding to the positive part, then it's a straight line for 0. So the first thing that you can do is you can take this +5, -5 volt LFO signal, and if you add 5 volts to it, it'll turn it to 0 to 10. So then this control would respond to the full range of the sweep of the sine wave. This is a signal processor. It has a top and then a bottom that's simpler. You have a gain control and an offset control. The offset will add up to 5 volts positive or 5 volts negative to any input. So first, I'm going to take the output of the LFO. I'm going to bring it into the input of the top version of the signal processor. And then let's see if this will reach. I'm going to take the output of the signal processor back into the depth input. Now notice we're not seeing anything because gain is set to 0. If I turn it up to 100%, that's going to be roughly what it already was. Now, if we turn the offset all the way up to 5 volts, now this is sending 0 to 10. Notice that it no longer stops here. If you don't have the offset, it goes down to 1 and then off. So if you're feeding in something here and here, or something in 3 inputs or 4, more often than not for my uses, I have not wanted it to completely shut off. If these are different speed LFOs, for example, I don't want it to ever completely shut off. I always want to have something going out. So notice when I bring in the 5 volt offset now, and I'll slow the LFO down just a tad, now it always stays lit. But the problem is it's going way past here. And I have found initially with this that it took a little while screwing with it. You have to screw with the depth control and with the gain coming out of the signal processor to get it to go perfectly from 1 up to 4, staying on, down to 1, and staying on. So let me show you this. If you turn this down, notice this is how much this is listening to, so we lose 1 again. So what if we turn this down? Okay, now it's not going down far enough, which means we should be able to turn this up. Nope, let's turn it down. Okay, look at this, look at this. It's almost there. Let's turn this down just a tad more. Okay, look at that. All right, so for those of you who want to use it like this, here's the settings. I'm coming out of an LFO into the control input. If you use a patch where you're using all 4 of these LFOs into all 4 processing inputs, which is very cool, setting them for slightly different times and 2 of them square wave and 2 of them sine. If you use a different LFO, like one of the Q106s or the simple LFO that's over here to the right, you can do the same thing, but you might have to dial these in a little bit. Using the output of this LFO, I've got the 5-volt offset full up. I've got the gain here at about 75%, right between 50 and 100. And I've got the depth amount just about 2.5 or just under 2.5. Now, what slopes does is it adds each one. So that would give you a composite output waveform if you had 4 different LFOs here. That's the difference between peak and slope. Also, if you play with the width, it will, instead of kind of switching between, it will crossfade. So watch what happens when I bring the width up. See? So again, there you go. Now, I'm curious myself, what would happen if I wanted to use all 4 of these into the signal inputs so I no longer have this as a modulating LFO? What if I was going to use the Q106 over here to the left? All right. I'm going to plug into the positive output of the Q141 that's just over here, just to the left. I'm going to set it to a sine wave and see what it does. Okay, so this tells me that the Q141, the synthesizers.com oscillator LFO, is putting out slightly more voltage than the SSL. So I'm actually down here to the left, the output level of the Q141. I'm going to back it off a little and see what happens. Okay. Now I've got the output level at 8. It's about 3 o'clock on a clock dial. That's a sine wave. Let's change it to a triangle. Back to a sine. Interesting. How about a sawtooth? Rising ramp. And of course, if you went to a square wave, it should go back and forth. So something else that you can do, if you're adventurous, is you could take this LFO signal, run it into a mixer, take a second LFO, also as a control source, into a mixer, make a composite complex sub-audio rate control signal into here to have it sometimes doing this and other times going up or only down. Then if you're feeding, for instance, if you're using audio signals, you could feed in 4 oscillators playing different pitches, make kind of a sequence. You can actually have the oscillators add. Now that's the waveform. Let's come back to a sine, see what happens. Okay, so that would actually be giving you a harmonic set with one note adding 2, 3, and 4, and then down. Now it would like a chord, and then the top notes, well, depending on what they were, this note would drop out one at a time. Pretty cool, huh? And if we go back to peak and we open up the width, now you would be hearing dyads. Dyad here, dyad here, dyad here. You could come out of a single oscillator in different waveforms. A square wave, a pulse wave with a 20% duty cycle, which will sound much more nasally. A sawtooth. You could take one of the waveforms from the wave plane that's wacko or crazy. You could even do something like bring in an audio rate waveform, sine wave or tri, sub-audio rate waveform, sine, tri, whatever, audio rate, sub-audio rate, and then feed this out into modulating an oscillator so the oscillator will go back and forth between FM, audio rate modulation of the oscillator, sub-audio rate, vibrato, FM again. You see the possibilities with this. So guys, when you go to use this, the last point is plan on having to kind of dial in this and dial in this, but now you're seeing the utility of a signal processor and that 5-volt offset.